So for our chapter, we have chapter 2, and in our group we have John, Christine, Carl, Alejandra, Alan, and Abriana. First, we'll be talking to you about the history of probability. So, the Nuova Cronica, a 14th century history of Florence by the Florentine banker and official Giovanni Villani, includes much statistical information on population, ordinances, commerce and trade, education, and religious facilities, and has been described as the first introduction of statistics as a positive element in history. Through neither the term nor the concept of statistics has a specific field yet existed. The mathematical methods of statistics emerged from probability theory, which can be dated to the correspondence of Pierre de Fermat and Blaise Pascal, 1654. Christian Huygens, 1657, gave the earliest known scientific treatment of the subject. Jacob Bernoulli's Ars Conjectandi, Posthumus, 1713, and Abraham de Moivre, The Doctrine of Chances, 1718, treated the subject as a branch of mathematics. In the modern era, the work of Kolmogorov has been instrumental in formulating the fundamental model of probability theory, which is used throughout statistics. Now we're going to talk about definitions of probability. And one definition is: an experiment is an act or process of observation that leads to a single outcome that cannot be predicted with certainty. The next definition is: a sample point or a sample space is the most basic outcome of an experiment, and sample space is the collection of all its sample points. Another definition is an event, which is a specific collection of a sample point, and all possible outcomes are called sample space. A random variable is a variable that assumes numerical values associated with the random outcomes of an experiment, where one and only one numerical value is assigned to each sample point. A random variables that can consume a countable number of values are called discrete. Random variable that can assume values corresponding to any of the points contained in one or more intervals are called continuous. The probability of distribution of a discrete random variable is a graph, table, or formula that specifies the probability associated with each possible value the random variable can assume. In this chapter, we are looking at two operations on probabilities which divide into three different cases. The two operations are additive rule and conditional probability rule. The three different cases are general, mutually exclusive, and independent. So the equations for mutually exclusive is probability of A and B equals 0, and probability of A or B equals probability of A plus probability of B. Another equation is the probability of A divided by the probability of B equals the probability of A and B over probability of B equals to 0 over probability of B, which gives evidence to probability of A divided by probability of B equals 0. For the second case, there are two operations for the general formula, which is the additive rule, and the formula for that one is probability of A or B equals probability of A plus probability of B minus probability of A and B. For the conditional probability, it's the probability of A divided by probability of B, which equals to probability of A and B divided by probability of B. For the last formula, it's going to be the independent formula, which will be probability of A and B equals the probability of A times probability of B. We also have the probability of A or B equals probability of A plus probability of B minus the probability of A times the probability of B. Another one is the probability of A divided by B, which is the probability of A times the probability of B divided by the probability of B. And then another one is the probability of A divided by B equals the probability of A. Now we're going to show you a card that's selected from a deck to find a probability. So say you want to find a probability of an ace, it would be probability A equals 4 over 52, which is reduced to 1/13 because there are 4 aces in a deck. If you wanted to find a probability of a jack or spade, you would put probability of jack or spade equals the probability of jack plus probability of spade minus probability of jack and spade, which would conclude to 4 over 52 plus 13 over 52 minus 1 over 52 equals to 16 over 52 and reduces to 4 over 13. Next, we're going to figure out the probability of a jar that contains 6 red, 7 white, and 7 marbles. If a marble is chosen at random, find the following probabilities. So say if you want to find the probability of a red marble, the probability would be P of R equals 6 over 20 because there are 6 reds out of 20 marbles total. Say if you want to find white marbles, it would be P of W, which is white marbles, equals 7 over 20 since there are 7 white total. If we want to find the probability of red or blue marbles, it would be probability of R or blue equals to probability of red plus probability of blue minus probability of red and blue, which equals to 6 over 20 plus 7 over 20 minus 0. Now we're going to talk about the probability of 2 dice being rolled. So say you want to find the probability of the sum of the dice equaling to 5. It would be P sum is 5 equals to 4 over 36 because the first die could be 1, second die could be 4. The first die for the next one can be 2. The second die for the next one would be 3. And then the first die would be 3. And then the next die would be 2. And then the first die would be 4. And then the next die would be 1. So that would equal up to 4 out of 36. If you want to find the P sum of 8, it would equal to 5 over 36. And you would get 2 plus 6, 3 plus 5, 4 plus 4, or 5 plus 3, or 6 plus 2 to equal up to 8. And that would be the result of 5 options out of 36. If you like to find the P sum of 3 or 6, it would equal to 7 over 36. If you want to find the P sum more than 10, it would be 3 over 36. Next, we'll be finding the addition rule to find the following probabilities. So one question will be, a card is drawn from a deck and the events C and D are as follows. C equals it's a king, D equals it's a heart. So you use the addition rule equation would be probability of A or B equals probability of A plus probability of B minus probability of A or B. So probability of K would equal to 4 over 52. Probability of H would be 13 over 52. So it would be probability of K and H equals 1 over 52. So it would be a probability of a king or a heart equals 4 over 52 plus 13 over 52 minus 1 over 52, which equals to 16 over 52. The next problem would be a dice is rolled in the events E and F are as follows. E equals an even number shows. F equals a number greater than 3 shows. So to use the same equation, it would be probability of E or F equals probability of E plus probability of F minus the probability of E and F. And the numbers would be 3 over 6 for even numbers that show, plus 3 over 6, which are numbers greater than 3 that shows, minus 2 over 6 equals 4 over 6 and is reduced to 2/3. The next problem would be 2 dice are rolled and the events G and H are as follows. G equals the sum of dice is 8. H equals exactly 1 dice shows a 6. Find P, probability of G or H. So you use the equation probability of A or B equals probability of A plus probability of B minus probability of A and B. Probability of G would be 5 over 36, for the sum of dice is 8, and then probability of H, which is exactly 1 dice shows is 6, equals 10 over 36. And you do probability of G or H equals 5 over 36 plus 10 over 36 minus 2 over 36, which equals to 13 over 36. And the last problem to find the probability of addition rule is 3 coins are tossed and the events I and J are as follows. I equals 2 heads come up, J equals at least 1 tail comes up. Find probability of I or J. So you do the equation again would be probability of A or B equals probability of A plus probability of B minus probability of A and B. So probability I would be 3 over 12 for 2 heads that come up. Probability of J would be 9 over 12 with at least 1 tail comes up. And the probability of I and J equals 2 over 12. So the problem would be 3 over 12 plus 9 over 12 minus 2 over 12. Now we're going to do problems with the following involving independence. So if probability of E equals 0.6, probability of F equals 0.2, and E and F are independent, find probability of E or F. So the first step you want to do is find probability of E, which equals 0.6, the probability of F equals 0.2, and the equation you want to use for these two are probability of E and F equal probability of E times the probability of F equals 0.6 multiplied 0.2 equals to 0.12. You then take that number and you put into the equation of probability of E or F equals the probability of E plus probability of F minus the probability of E and F, which will result to 0.6 plus 0.2 minus 0.12 equals to 0.68. Now, another question would be if P equals 0.6 and P probability of E or F equals 0.8 and E and F are independent, find the probability of P. So first you want to find the probability of E, which is 0.6, and then the probability of E or F equals 0.8. You want to then do the probability of E and F equals the probability of E times the probability of F, and the probability of F equals X. So the equation you want to use is the probability of E or F equals the probability of E plus the probability of F minus the probability of E times the probability of F. So it would be 0.8 equals to 0.6 plus X minus 0.6 X. So then you would do 0.8 equals 0.6
plus 0.4x, and then you would get 0.2 equals 0.4x, and then x would be by itself, and then it would be 0.2 divided by 0.4, therefore x equals 0.5. Another one would be John's probability of passing statistics is 40%, and Linda's probability of passing the same course is 70%. If the two events are independent, find the following probabilities. P, both of them will pass statistics, and then another probability would be at least one of them will pass statistics. So what you have is probability of J, which is John, equals 0.40. Probability of L, which is Linda, is 0.70. Your equation would be probability of J and L equals to probability of 0.40 times probability of 0.70, which equals to the probability of John and Linda equals to 0.28. If you want to do the probability of John or Linda, it would be 0.40 plus 0.70 minus 0.28, which equals to 82%. Next, we're going to talk about the binomial probability. You have to use your calculator for this to type in a value. So in your calculator, you go to Math, then Probability, then you choose NCR, type in the x value, and then it gives you your number. The binomial equation is P of x equals to n choose x times p to the power of x times q to the power of n minus x. N is the number of trials, x equals the number of success, p equals the probability of success, and q equals the probability of failure. So an example is the probability of exactly 9, and n equals 10, x equals 9, p equals 0.80, and q equals 0.20. So you would do 10 choose 9 in your calculator, which gives you 10. You do 0.80 to the power of 9, which gives you 0.13, and then you do 0.20 to the power of 1, which gives you 0.20. So your result is 10 times 0.13 times 0.20, which gives you 26.84.
Another binomial probability question will be, a coin is tossed 10 times. Find the probability of getting 6 heads and 4 tails. So you need to find your n, your x, your p, and your q. So your n equals 10, your x equals 6, your p equals 0.50, and your q equals 0.50. And the binomial equation is n choose x multiplied by p to the power of x multiplied by q to the power of n minus x. It'd be 10 choose 6 multiplied by 0.50 to the power of 6 multiplied by 0.50 to the power of 4. You then get 210 multiplied by 0.0156 multiplied by 0.0625 results to 0.20475, which is 20%. Next, on another binomial probability question will be, a family has 3 children. Find the probability of having 1 boy and 2 girls. So you need to find your p, your q, your n, and your x. Your p will equal to 3 over 8. Your q will equal to 5 over 8. Your n will equal to 3. And your x will equal to 1. The binomial equation is n choose x multiplied by p to the power of x multiplied by q to the power of n minus x. It will result in 3 choose 1 multiplied by 3 over 8 to the power of 1 multiplied by 5 over 8 to the power of 2, which will then be 3 multiplied by 0.375 multiplied by 0.3906, which will equal to 0.3483, which will equal to 35%. Here is another binomial probability question. What is the probability of getting 3, 1 if it is rolled 5 times? So you need to find your P, your Q, your X, and your N. Your P will equal to 1 over 6. Your Q will equal to 5 over 6. Your X will equal to 3. And your N equals 5. So you can do the binomial equation, which is N choose X multiplied by P to the power of X times Q to the power of N minus X. So then you would get 5 choose 3 multiplied by 1 over 6 to the power of 3 multiplied by 5 over 6 to the power of 2. You then get 10 multiplied by 0.0046 multiplied by 0.694 equals to 0.0319, which equals to 3%.
Now we're going to do a binomial problem. So the problem is, with a new flu vaccination, 85% of the people in the high-risk group can go through the entire winter without contracting the flu. In a group of 6 people who were vaccinated with this drug, what is the probability that at least 4 will not get the flu? So step 1, you need to find P, Q, N, and X. Step 2, you need to do the probability of exactly X equals to the equation of N choose X multiplied P to the power of X multiplied Q to the power of N minus X. So P for this equation would be 0.85, Q would be 0.15, N would be 6 since there's 6 people, and X equals 4, 5, and 6 because it says at least will not get the flu. So your first one would be P of the probability of X would equal to 4. Your equation will look like 6 choose 4 multiplied by 0.84 to the power of 4 multiplied by 0.15 to the power of 2. The result of that would be 15 multiplied by 0.85 to the power of 4 multiplied 0.15 to the power of 2, which results to 0.176. The next one will be the probability of X equals 5, and it will look like 6 choose 5 multiplied by 0.85 to the power of 5 multiplied 0.15 to the power of 1, which equal to 6 multiplied 0.85 to the power of 5 multiplied by 0.15 to the power of 1 equals to 0.399. And the last one you have to do is the P equals to the X equals 6, which the equation would be 6 choose 6 multiplied by 0.85 to the power of 6, 0.15 to the power of 0, which results to 1 multiplied 0.85 to the power of 6 equals to 0.377. Therefore, once you get all your X values that are needed, you need to add them up. So you add up to the X equals 4, X equals 5, and X equals 6, which gives you 9.52. Our last binomial problem is a telemarketing executive has determined that for a particular product, 20% of the people contacted will purchase the product. If 10 people are contacted, what is the probability that at most 2 will buy the product? So you need to find your P, your Q, your N, and your X. So P would equal to 0.20, Q would be 0.80, n would be 10, and x is 0, 1, and 2. So you'll have three binomial equations to add up. The first one is x equals 0, which equals to 10 choose 0 multiplied by 20 to the power of 0 multiplied by 0.80 to the power of 10 equals to 0.107. Your next binomial equation will be x equals 1. So it would be 10 choose 1 multiplied by 0.20 to the power of 1 multiplied by 0.80 to the power of 9 equals to 0.268. And your last binomial equation will be x equals 2, and that will equal to 10 choose 2 multiplied by 0.20 to the power of 2 multiplied by 0.80 to the power of 8, which equals to 0.301. When you add it all up, you will get 68%. So your final equation would be P equals to, at most, 2 equals to 68%. The last thing we'll be talking about is expected value. The first step is read the question and make a chart. Step 2 will be multiply x multiplied by p of x. And step 3 would be expected value and add up the x multiplied by p of x. So our first question will be, you are about to make an investment which gives you a 30% chance of making $60,000 and 70% chance of losing $30,000. The question is, should you invest? So you first need to make your chart. The first one would be x. The next section would be p of x. And the third section would be x multiply p of x. So in the x section, you need to put 60,000 because you can make a chance of making 60,000. And then it would be negative 30 below the 60,000 because you have a chance of losing it. In your p of x, it will be 0.30 for your percent next to 60,000 and 0.70 next to the negative 30,000. You then multiply them and add them up, which result to 18,000 with negative 21,000. And when you add it up, you get negative 3,000. So therefore, you should not invest because you will lose 3,000.
Another expected value question reads, in a town, 40% of the men and 30% of the women are overweight. If the town has 46% men and 54% women, what percent of people are overweight? So you need to make your x chart, the p of x chart, and then multiplied x of p of x. So in the x column, it would have 0.40 and 0.30. In the p of x column, it would be 0.46 and 0.54. And once you multiply those together, you get 0.184 and 0.162. And once you add it all together, you'll get 0.346, which will add up to 35% of people are overweight.
Another question is, a game involves drawing a single card from a standard deck. One receives 60 cents for an ace, 30 cents for a king, and 5 cents for a red card that is neither an ace nor a king. If the cost of each draw is 10 cents, should one play? So you need to make your chart, the x values, which will be 0.6, 0.3, and 0.05. And the next column would be p of x equals to 4 over 52, 4 over 52, and 22 over 52. And when you multiply these x and p of x together, you get 0.046, 0.023, and 0.021. which will add up to 0.09, and you minus the 0.10 for each cost, and you lose 1 penny.
And this expected value problem reads, in a European country, 20% of the families have 3 children, 40% have 2 children, and 30% have a child, and 10% have no children. On average, how many children are there to a family? So you need to make your x chart, p of x chart, and multiply x of p of x. So in your x column, it would be 3, 2, 1, and 0. Then the p of x column would be 0.20, 0.40, 0.30, and 0.10. Once you multiply those together, you result in 0.6, 0.8, 0.3, and 0. And once you add it up, it would be average 1.7 children to a family. Another expected value question reads, Hillville Church plans to raise money by raffling a television worth $500. A total of 3,000 tickets are sold at a $1 each. Find the expected value of the winnings for a person who buys a ticket in the raffle. So you need to do the x column, the p of x column, and then the x times p of x. In the x column, you'll have 500, 0, and negative 1. In the p of x column, you'll have 1 over 3,000, 2,999 over 3,000, and 1. When you multiply these together, you'll get 0.167, 0, and negative 1. And once you add it all up, you'll result to negative 0.833. So you'll lose 83 cents.
The next problem is, during her 4 years at college, Nikki received A's in 30% of her courses, B's in 60% of her courses, and C's in the remaining 10%. If A equals 4, B equals 3, and C equals 2, find her grade point average. So you want to make the chart again. And in the X column, for A would be 4, B would be 3, and C would be 2. In your P of X column, it would be 0.30, 0.60, and 0.10. When you multiply these two together, you get the result of 1.2, 1.8, and 0.2. When you add up all these averages, her average GPA is 3.2. Our next problem is, attendance at a Stanford football game depends on the team facing Stanford. If the game is against UC Berkeley, the attendance will be 70,000. And if it is against another California team, it will be 40,000. And if it's against an out-of-state team, it will be 30,000. If the probabilities of matches are 10% for UCB, 50% for CA team, and 4% for out-of-state, how many fans are expected to attend the game? So you need to make your chart, and for the X column, you would put 70,000, 40,000, and 30,000. For the P of X column, you would put 0.10, 0.50, and 0.40 for the percentages. When you multiply these together, you will get 7,000, 20,000, and 12,000. So your end result for the fans that are expected to attend a game are 39,000. Our last expected value problem will be, a game involves rolling a Korean dice, which are 4 faces. If a 1, 2, and 3 shows, the player receives the face value of the dice in dollars. But if your 4 shows, the player is obligated to pay $4. What is the expected value of the game? So in your X column value would be negative $4, positive $3, positive $2, and positive $1. In your P of X column, it would be 1/4, 1/4, 1/4, 1/4. When you multiply these all together with the X multiplied the P of X, you'll get -1, 3/4, 2/4, and 1/4. So when you add it all together, you get 2/4 equals to 1/2.